All right. All right. Hello, everybody. Thank you for listening in. This is our final presentation for MSDS 498 in Dr. Wedding section. Our group, which adopted the team name of Mind the Data LLC, will be sharing a portfolio of analytics work that we prepared for New York City's Metropolitan Transportation Authority, or NYCMTA. That includes modeling, reporting, database work, and interactive app development. Before diving into the project work, I'll just do a quick introduction of our team, and then I'll go into some additional context that's highlighting some of the problems that are facing the NYC MTA that we hope to address with this analysis. So for starters, this is our analytics group of 5 team members strong. We each took on kind of a different domain of work, and that's listed here for reference. We won't go into the specifics quite yet. But each of us throughout this presentation will kind of walk through the contributions that we made and our focus for the project. So that said, I'll dig into the problem statement a little bit that we're hoping to address in this portfolio of work. For starters, the COVID-19 pandemic really did a number to NYC's MTA. We saw throughout the pandemic a 60% decrease in ridership, and ridership is the primary revenue generator for the MTA. You can think of that, simply speaking, as riders swiping their cards to board the subway. And because of this, in the middle of the pandemic, the MTA was actually prompted to submit an emergency request for about $4 billion in 2020 just to sustain operations and keep the lights on throughout the pandemic. A couple of years removed from the pandemic, the MTA is still very much in recovery mode. To support maintenance, operations, and expansion projects, New York City actually introduced a $65 billion plan in September of this year. And while that's exciting, that's actually still just only covering a fraction of the estimated total need of the MTA, which exceeds $115 billion for future route expansion and maintenance projects. So all that said, the $65 billion in funding is a very optimistic step forward, but because it cannot cover the extent of all the MTA's need, strategically investing that money will be more important now than ever. And this is where our team, Mind the Data LLC, intends to step in to provide analytics insights that ultimately help the MTA meet growing ridership demands and improve the ridership experience, with the aim being to bring the MTA back to where it was pre-pandemic. So that said, we'll be diving into these solutions throughout the rest of this presentation. And you'll notice that each of them click into this overall mission of increasing and sustaining increased levels of ridership to create sustained revenue in the future for the MTA. So that said, I'll get started by sharing a bit about our ridership forecast project to get us started here. So the objective of our time series forecasting and ridership forecasting was to leverage a wide range of time series forecasting algorithms to generate an accurate forward-looking prediction at daily subway ridership. Now, this is important. Leveraging a ridership forecast will unlock planning opportunities for the MTA, enabling them to make network maintenance and expansion decisions that are cognizant of ridership demand. And simply speaking, we can think of ridership as being a primary top-line input to a lot of the strategic decisions that the MTA is looking to invest in. So with that said, our discovery and development of a time series forecasting model for future ridership was approached in kind of a phased approach. Starting with the data, we leveraged MTA's data API to pull daily ridership numbers from the middle of 2020 through October of 2024. We additionally joined on and explored external data sets for exploration and importance. This included metrics pertaining to things like weather, population growth, employment rates, gas prices, holidays, etc. After forming a solid base data set, we got started conducting exploratory data analysis, exploring some of the external or exogenous features. Like I mentioned, population, unemployment, temperature, these were key inputs to some of this data analysis. Ultimately, to test and score different approaches to find a solution of best fit for ridership being the response variable. Linear regression and ARIMA were used as part of this EDA. This exposed what variables stuck as being important and causal to ridership and which ones weren't. It also exposed very strong trends of seasonality, both at the daily and the monthly level, that must be taken into account when thinking about future ridership. So that said, we proceeded into the next phase of work, which was kind of a structured modeling process, where we created an approach comparing different algorithms. Algorithms of interest included SREMA, SREMA-X, and Profit. For each of these models, we tested using grid search for hyperparameter tuning and 180 days of holdout data for validation. Between the three forecasting models of interest, we actually found that SREMA and Profit scored comparably well when looking at RMSE and MAPE for validation testing, both achieving a root mean squared error of about 6 to 6.5% and a MAPE of about 8.5%. Whereas SREMA-X, which included lots of exogenous variables, actually performed worse. And so I think this speaks to how many drivers of ridership there are and how hard it is to try to quantify that with external variables. And so the best signal we got was actually from historical ridership itself and just picking up on some of the underlying trend. So with that said, Profit and SREMA with comparable accuracy, kind of our quantitative approach to validating which model to move forward with. We layered on a qualitative check of looking at some of these predicted versus actual trends for holdout data. And we actually found that Profit did a very, very good job at capturing the daily and the monthly seasonality trends. And so kind of marrying together the quantitative validation as well as the qualitative validation, we decided to choose Profit as our best fit forecasting model for ridership. So with that, kind of the, I guess, more important piece for the MTA was using this final model to predict ridership into the future. We predicted ridership for 2025, and compared to 2024, we were anticipating about a 2.5% increase in daily ridership numbers. And so with that said, our hope is that this ridership forecast can serve as a key planning input, one that can be adopted and scaled by the MTA for other future planning processes, and can serve as a useful input in some of the planning activities as needed. So that said, this interactive tableau is embedded here on our MyWayMTA website, which can assess the profit forecast model, as well as some of its lower and upper bound prediction, factoring in profit uncertainty intervals. So that said, I will pass it over to Reese, who's going to dive into the route expansion component of this analytics portfolio.
Thanks, Sam. Now let me walk you through our route expansion strategy. First, we utilize the linear optimization model to prioritize route expansions. This model incorporates the MTA's key scorecard metrics, cost time savings, sustainability, capacity, and geographic distribution. These metrics ensure that every decision aligns with the broader goals of efficiency, accessibility, and sustainability. Next, we consider the budget and project concurrency. With a $65 billion budget, balancing multiple projects simultaneously is crucial to maximizing the impact while staying within financial constraints. Lastly, the selected routes for expansion are those that provide the greatest utility. By focusing on areas with the highest potential for impact, we can ensure optimal resource allocation and ridership benefits. This approach ensured we meet the MTA's goals while addressing immediate and long-term transportation needs. The first project we decided on choosing was the Utica Nordstrand Junction capacity improvements located down here. This project focuses on enhancing capacity and reliability at the Nordstrand Junction by adding 3 new crossovers and extending storage tracks south Crown Heights Utica Avenue. We're addressing a serious bottleneck for the Brooklyn IRT lines 2, 3, 4, and 5. With 319,900 daily riders and 8,700 new riders, this project is a critical investment. It scored a perfect 100 in the cost time savings, capacity, and geographic distribution scorecard metrics, and at a cost of $640 million, it's both impactful and cost effective. Our next project is the Utica Avenue Bus Rapid Transit. This initiative adds center running bus lanes between Kings Plaza and Woodhull Hospital, improving transit options for underserved communities. With 71,900 daily riders, including 3,900 new riders, and a cost of $300 million, this is a cost-effective solution for one of Brooklyn's busiest corridors. While it excels in cost time savings with another perfect score of 100 on the key scorecard metric, It also opens up opportunities for future development nearest underserved stations. The third project of the priority projects is the Ridgewood Busway. It repurposes a half-mile MTA-owned right-of-way into an exclusive busway, boosting speeds and reliability for local buses. This project serves 8,900 daily riders, including 200 new users. Despite its small scale, it scored 100 in the cost time savings metric and comes with a very low price tag of 30 million, making it an efficient investment for localized transit improvements. Finally, the Harlem Line capacity improvements add a third track and upgrade infrastructure along the Metro North Harlem Line. This $1.3 billion project enhances capacity, operational flexibility, and reliability, accommodating the 83,700 daily riders by 2045. It scored in high cost time savings at 89, while also supporting growth and improved service for key stations like Scarsdale and White Plains. Now the model also chose a number of other routes that were selected, but will need to be completed after these priority routes are done. These selected priority routes reflect the model's focus on maximizing value by prioritizing projects to deliver high daily ridership benefits and strong performance scores, all while maintaining relatively low costs. By choosing expansions that optimize cost effectiveness and align with key objectives like cost time savings, sustainability, and geographic distribution, the model supports the MTA's commitment to efficient, impactful improvements. Now I'll be passing off to Takeshi to go through our dashboard. Thank you.
Thank you, Reese. So we created the insights dashboard for the MTA board, and this dashboard is designed to deliver the actionable insights into the MTA operations, ridership patterns, and system efficiency. And so I'll just show you a demo of how this dashboard works. So it does contain two sections. The first one is the demographic insights. The second one is the congestion and bottlenecks. So the first one, the demographic insight, what it does is that it offers a comprehensive view of rider patterns across New York City with filters of borough, station, ridership, and year. And as you can see right now, you can see that the destination right now is going to Times Square, and right now it's a minimum of 10,000 ridership. You can change this to 20,000 and have that reflected. And also, I can choose instead of just coming from everywhere, I can just say I can choose like if it's from Queens, how many people are coming from Queens, and I can filter this throughout. So, and also the MTA itself, it always goes through most of the line goes through Manhattan, so there are a lot of underserved routes, especially around around Queens and Brooklyn. So for instance, I can do the origin going to Queen. I can select the destination going to Brooklyn, and then you can see that there are some riderships that so minimum ridership is a little too extreme, but it's 1,000. Yeah, so with these filters, you can see that there are some, there are a lot of demand in certain locations within the boroughs. So, anyways, the second part of the dashboard is the congestion and bottlenecks. And so this dashboard basically tracks 3 KPIs: the ridership, delays, and the weight assessment pass ratio. And just giving context, the weight assessment, it measures how regularly the trains are spaced during peak hours at selected time points on each line. So the pass ratio measures the ratio of trains that meet the weight assessment threshold, and the higher the pass ratio is, the better. So yeah. And for this, you do there are filters for month, and there's also a day type if it's whether a weekday or if it's a weekend. So you can see the distinction of which where the ridership delays are. And so yeah, and you can see if you click on these, it does highlight, for example, like line 2, it does have high ridership with a lot of delays and a low pass ratio. So this is so it's very easy to see that this train has a lot more improvement that's required. So, Yep. So and again, this dashboard is for the MTA board so that they can assess their current I guess their bottlenecks every month. So you can see, you know, for different months there are some different data points here. So you can kind of yeah, choose here. So okay. So thank you. And next I'm going to Claire for the route finder.
All right, so now to focus on tools for riders. With our Route Finder feature, we wanted to cater to the unique preferences, schedules, and priorities of the millions who rely on the MTA every day. And so we felt like one of the best ways to provide benefit to current and future MTA riders is by enhancing navigation tools that almost everyone uses today to get from point A to point B. So current tools like Google Maps, Apple Maps, even the current MTA app really just offer a one-size-fits-all approach to route recommendations, which can certainly fall short in meeting the diverse needs of users. So by leveraging the MTA's public data, we designed a route recommendation system that goes beyond just identifying the fastest route, as we demonstrated what it would look like for riders to personalize their journey by factoring in many things people care about on their journey, such as safety, comfort, accessibility, amenities, and efficiency. So before we dive into the demo, to touch upon the development of the tool, we rolled out these features in a few stages. So we started by simply collecting and cleaning the MTA station and line geometry data to be able to plot the subway network centered around New York City. Then in phase one, we used the network of stations and lines to be able to identify the best route from the starting to ending station using Dijkstra's shortest distance algorithm, which also factored in penalties for transfers. We also introduced a route scoring schema across 5 categories that I mentioned earlier, and I'll touch upon some of the specifics of these categories next. And in the final phase, we considered an individual's preferences to generate a route match score so that a router knows if a recommended route conflicts with the categories that matter most to them. So the initial release of Route Finder offers a single recommended route with a route match score based on the saved user preferences. Future updates can and will certainly take personalization even further by suggesting multiple route options to provide users with greater flexibility and choice. But what we have today just really gives you a preview of what is possible. So to get into the specific categories that users can rank, our recommendation system assigns routes a score out of 10, reflecting alignment with safety, which is based on the incident rates of the lines and stations included in the route. Amenities, which is captured by station Wi-Fi availability. Comfort, which is captured by the busyness along a route. ADA accessibility at the starting and ending stations of a route. And efficiency, which is based on line and station delays. So higher route scores reflect better overall conditions for passengers, and the route match score that is generated captures how well a user's preferences align with their recommended route. Okay, so now on to the demo. Okay, so on the front end of our app, the user would navigate to this magnifying glass here, and that would open up this Route Finder tab. And from there, you can see 3 different components. User preferences are on the left. You see the route map in the center, and then route scoring on the right-hand side. So we're going to pretend that it's a Monday morning and I am headed to work. So I'm going to order my preferences. Efficiency is going to be important to me. I want to make sure there aren't any delays, or I want to minimize the number of delays. Amenities is also going to be important to me. It'd be nice if I had Wi-Fi. Safety, not as important to me. Monday morning, maybe I care more about safety on a Friday. And accessibility isn't as important to me at this point. So we're going to save those, and then we are going to start off 59th Street. We're going to pretend that I live right by Central Park, and we'll go to Wall Street here. That will be my ending station. So I hit find route, and we can see this is actually a pretty straightforward route. There aren't any transfers, and we can see a moderate route to user match. So amenities, great, 10 out of 10. We have Wi-Fi along the route. So that that certainly helps the route match score here. Comfort also is pretty high on this route, so not the busiest route per se. Safety a bit lower, efficiency also low, so that would explain why this is a bit lower, since efficiency is important to me. If I actually go and knock efficiency down here and save preferences, we can see that the route match score jumped by 12% there. So it's pretty cool. You can kind of reorder these and see how it impacts the score. So I'm gonna try to quickly go through here a couple other examples. So we'll say I'm still in Lower Manhattan. We'll just change my starting station, and we're gonna pretend after work I'm going to East Village. So Bleecker Street here. We'll say my preferences are the same. Find route. Again, pretty straightforward route. No transfers here. This route, amenities very low here, so that would explain why 44% match. Accessibility scored higher, comfort scored higher, safety still pretty low, efficiency still pretty low, so some historical delays along this route. So if I go and bump this down, I'm gonna mess with this a little bit, and we can see another pretty big jump here just by, if I were to say accessibility and comfort are more important to me, since this route scored well in those two categories. But now we'll do one more example here. We'll go from Bleecker Street. So we'll go from dinner. We'll pretend I'm going to a game. Let's see. There it is, Atlantic Ave. All right, so this, we actually have a transfer. And we can see at this station, for this route rather, safety is pretty low, comfort's pretty high. We can see a pretty high route to user match. That's because I have accessibility bumped up. If I go and bump that down, we'll say I bump amenities up. We'll say I want to get there quickly. Efficiency is important to me. We can see that route to user match goes down. So indicating that based on the preferences I set, this probably isn't the best, a great route for me. It might be the best one, but it definitely doesn't fully meet my needs. So that just is a little preview of what Route Finder looks in this first release of MyWayMTA. In future releases, along with this multi-route recommendation feature that I mentioned earlier, we plan to make the category scoring a bit more robust, incorporating some more real-time data to really hone in on the current status of lines and activity at stations. But for now, I'll hand it over to Kevin, who's going to talk about another pretty cool feature that we have for riders called Route Builder.
Great. So the complement to our Route Finder feature is the Route Builder feature. This interactive map-based tool allows for creative route planning, where users can visualize their ideal subway lines by selecting starting points and connecting them to existing or prospective stations. The inspiration for the Route Builder feature stems from our initial analysis of the MTA's rider sentiment survey responses. We found that despite millions of annual riders, the MTA's most recent survey tallied a mere 80,000 responses. So to bolster rider response rates, we embraced a gamified approach to gather valuable data and insights on rider preferences and priorities. While we do recognize that not all of these routes will be feasible, the intention of the app feature is to equip the MTA with valuable insights into rider sentiment that might otherwise not be captured via the existing surveys. So with that, I will jump into the app components. We see here, pictured center, the core feature of the Route Builder. Now, users can start by selecting a point on the interactive map. This will be our starting point for our prospective route that we will be building. You can see here, as I click onto additional points, our route starts to take shape. If in the event a user wants to retract, pivot, change direction, all is fair on the Route Builder app. Now, users, if after some time decide that they want to start over, we can simply refresh and start again. To the left is our detail view. So the detail view provides a clear sequence outline of our customized routes, and it lists all the stations here, as well as the distance and the total number of stops. So users can go in and name their custom route, save this route. You'll notice now it is isolated. And what we're doing on the back end is capturing this route for future reference. And what I mean by that is the leaderboard feature here, which you can see if you toggle over to this little trophy icon, it contains a summary list of all the created routes by various users. Users can share these and then also vote on them. And here we can see that feature. In doing so, we hope to foster a sense of community on the MTA app that not only allows users to express their unique preferences, but also vote on collective interests or potential opportunities for the MTA to explore. Now, against some of the survey responses and some of the more traditional mechanisms to garner key insights into their ridership and demand, we thought this was a fun and engaging alternative that we hope will bolster that engagement and bolster response rates throughout all of the users on the app. With that, I want to say thank you on behalf of the entire Mind the Gap team. We appreciate you taking the opportunity and the time to review our analysis and our final features. One piece I did want to call out before we hop off, we put together this web app to showcase the features and functionality that we've developed, and we hope that you will take the opportunity to access this yourself. You can go to MyWayMTA.com, where you can engage with both the app features, check out the dashboards we just explored, read more into all of our prospective expansion recommendations, and collectively, we hope you'll get a holistic understanding of not only our approach, our insights and analyses, but also to come away with some ideas of how this data can help inform the MTA both now and in the future. Thank you.